You think that's a fly cutter? That's not a fly cutter. That's a fly cutter. As you've probably guessed, I'd like to make one of those giant fly cutters that everyone seems to have. For those of you who don't know, a fly cutter is simply a tool that you use to face pieces of stock and leave really good surface finishes. And making a big fly cutter is something that I've always wanted to make, or at least since I saw the one that Chris at Clickspring made. I mean, who else wouldn't want a giant spinning wheel of death to use? Now, if that wasn't reason enough, I do have an upcoming project where I will need to face a really big piece of stock, and I don't think my current fly cutter is going to cut it. Now, of course, I could use a longer tool holder, but it would mean having quite a lot more stick out on this relatively small fly cutter, and that would have the tendency to chatter. You could also do it in 2 or 3 passes, but then you would end up with multiple sets of tool marks, and that's something that I really don't want to end up with on this part. So between you and me, that is enough reasons to make one of those big fly cutters, so let's get started and see what we can make. Now, the overall design doesn't need to be too different from my other fly cutters, but what is going to be different is that the main body is going to be made from aluminium rather than steel. What I have here is a piece of 200mm round bar, and it's about 35mm thick. According to the guide that I bought it from, it is 6061 grade, which really isn't my first choice for machining. It does tend to be a bit gummy, but we can machine it and it should be just fine. Now, with it being aluminium, it is going to be a bit lighter than if I'd chosen steel, but there is still a hunk of mass in this stock, and given the workload that I'm expecting to put this through, aluminium should be just fine. What isn't going to be aluminium though is the shank, and unlike most of my tools, which use a 20mm shank, I'm planning on pressing in a Morse taper shank. It's going to be a bit more rigid, and a lot more of the tool is going to be held in the mill spindle, and that makes me feel a bit more comfortable given how large this tool is going to be. And unlike Chris, who uses high-speed steel as his cutter, I'll be relying mostly on carbide button inserts to do most of my cutting. They're good inserts and they leave really great finishes in most metals, but I am going to have to make up a set of holders to hold them in the fly cutter. First things first though, we need to clean up that piece of aluminium, and already we're going to run into a bit of a problem. Normally you'd be able to do this in the lathe in about 5 minutes flat, and whilst it will physically fit on this lathe, it's about 50mm too big for the chuck that I have, and about 10mm too big for the faceplate. So I'm going to have to think of another way of cleaning this piece up. And the answer simply is to clean it up on the mill using the 2-piece vise and the new soft jaws that I recently made. Oh great, looks like I need a fly cutter to make a fly cutter. Looks like it's going to be one of those parts. And that's the aluminium cleaned up on the top and bottom. It left a pretty nice finish, but you can probably see what I mean about it leaving 2 sets of tool marks. Now you can't feel the difference between the 2 tool marks, it's purely aesthetic, but if I can avoid it in the future using a big fly cutter, that would be really nice. I can now mark up the stock and roughly find the centre of the workpiece. And from now on, this will become the center point for all future cuts. We can now start to machine a 25mm hole through the workpiece. I'll first start off with drilling. And now I can take it to final size with the boring head. With the bore now made, I'll start to machine a counter bore on one side of the part. This recess is going to be for a retaining cap, and that's going to help keep the arbor in place. With the recess now done, I'll start to machine in a slot for the cutter holder. The holder is going to be adjustable to allow you to change the position of the cutter, hence the need for the slot to allow you to adjust it. And in hindsight, the coolant probably wasn't all that necessary, but it did do a good job at flushing away all the chips, and that should extend tool life. But in the future, it's probably a lot easier to use an air blast or a vacuum cleaner to get rid of those chips. Final thing left to do is make a recess on each side of the slot, and that will help locate the holder. And that's not the main body done, but that's as much of the main body that I can do for the moment. Now the milling machine that I have uses a number 3 Morse taper spindle, and that taper needs to be very accurately machined when you're making tooling for this milling machine. And the easiest way to do that is to simply copy an existing Morse taper. I can then set up the compound to match that angle using a test indicator, and that's mostly a process of sweeping the part, followed by hitting the lathe with a hammer and hoping something happens. With the compound now set up to cut that taper, I can now set up a piece of stock and get it cleaned up and roughed down to size. With the stock now roughed down to size, I'll lock the carriage in place and start to cut the taper using the compound. And that, in theory, is a number 3 Morse taper. And that's a good as fit as any other Morse taper tooling that I own. Actually, I'm not going to be able to get that out. Gonna need to get a drift key in there. I don't know. That's a pretty good fit if you ask me. The final thing left to do is machine a shaft on the end of the shank. Now the 3-jaw has too much run out in it, so I'll machine it directly using the spindle taper. Alright, well that went in quite nicely. I think it could have been a hair tighter, but that is still a really good fit. Now even though I do have a nice press fit, I still don't trust only the force of that fit to keep the two parts together when machining. There is a lot of mass in the fly cutter and I really don't want to risk it coming off. So what I'll do is I'll machine a cap to keep everything sort of sandwiched together. I've added a bit of Loctite to the threads of that M10 bolt, and that should be enough to hold it all together. Of course though, we're still not finished yet. We still have to machine the side face of that aluminium to clean it up. And of course, because we now have a Morse Taper 3 shank, we can now use it to hold the part in the lathe. And I'm going to be using my live center here to simply stop the part from moving forward. There's no drawbar holding the Morse taper in place, so in order to prevent it from coming loose, I'll simply prop up the center against the part and I'll take light cuts, and that should keep everything nice, tight and rigid. And that's the main body of the fly cutter done. Overall, it's turned out looking really great. The final thing left to do is make some tool holders, which I can make from some offcuts of steel. The offcuts are looking a bit rough, so I'll first clean them all up with the face mill. And that is the tool holder done. As you can probably see, there's space on both sides for a cutting insert, and that will allow me to flip the tool holder in order to reduce the diameter. Final thing left to do is machine up a matching clamp. Whoa, that is one big fly cutter. Now, as you can probably see, I haven't really bothered to add any counterweights on the other side to sort of counterbalance it, but I don't think it's going to be too lopsided enough to worry about doing that, at least with the speeds that I'm going to be running this at, i.e. less than 1000 RPM. But obviously, if it does cause a problem, I will add one. Enough talking though, let's see how it actually performs. Definitely not the quickest way to face off a piece of aluminium, but that is a fantastic finish and it's a lot better than the smaller fly cutters. Let's try steel. Now, it definitely took a bit of time to nail down the correct speeds and feeds, but in the end, I found a nice sweet spot. I think it might be worth trying out a slightly sharper insert, at least in steel, but overall, the surface finish that I'm getting from this part is really great. Overall, pretty great tool. It's obviously not about to replace my smaller fly cutters, but at least for really large work, it can definitely get the job done in one pass. Overall, I'm so happy that I finally got around to doing this project. It was a lot of fun, and I just love the fact that I have such a big fly cutter now. Thanks for watching.